Assalamu alaikum everyone. Welcome to Goni's classroom. Today we are going to study chapter 11 of Edexcel IGCSE 91 chemistry syllabus, and the name of the chapter is the Alkali Metals. And in this chapter we'll be discussing about these topics. Okay, the contents of this chapter are why they are in group 1, why they are called alkali metals, some of their physical properties, how to store and handle them, why they are a family of elements, and some reactions of these elements. And later we will be discussing about the trend in reactivity of these elements, and finally we'll be able to predict the physical and some chemical properties of francium. Okay, let's start. First, we'll be discussing why they all are placed in group 1. Okay, let's see the electronic configuration of the elements, some of the elements in this group. Okay, lithium 2,1, sodium 2,8,1, potassium 2,8,8,1, and if you further go down, you'll see that this one also has 1 electron in its outer shell. Okay, all of these elements have 1 electron in their outer shell. Look at this. Every element of this group has 1 electron in their outer shell, and this is the number of electrons in the outer shell that determines in which group they should be placed. Since all of them have 1 electron in their outer shell, they all are placed in group 1. Okay, we have discussed this content. Now, why they are called alkali metals? They all react quickly with oxygen in the air to form oxides, and those oxides are base, and these elements react rapidly with water to form strongly alkaline solution. Therefore, they are called alkali metals. Again, repeating the topic, why they are called alkali metals. All of these elements react quickly with oxygen in the air to form oxide. Let's see a reaction between sodium and oxygen. Okay, and they also react rapidly with water to form a strong alkaline solution, and hydrogen also. Okay, since they react with water to form an alkaline solution, and the oxides formed actually is also a base which dissolves in water to form again an alkaline solution. That's why they are called alkali metals. Okay, now let's study their physical properties. Okay, we have learned why they are called alkali metals. Now, physical properties. First, we'll be talking about their melting and boiling points. All these elements actually, though they are metals, despite being metals, they all have very low melting and boiling points, and melting and boiling points again decreases down the group. Okay, despite being metal, though they are metal, but they have very low melting and boiling point, and again their melting and boiling point decrease down the group. Okay, now density. Okay, but density increases down the group. As you go down the group, the density increases. But the density of these metals are not that high. They have very low density, and the density increases down the group. Lithium, sodium, and potassium, these three elements in the group 1 are less dense than water, therefore they float onto water. Water has a density of 1 gram per cm cube, and lithium, sodium, potassium actually have density below 1 gram per cm cube. Okay, lithium, sodium, and potassium, these three metals have densities that are lower than that of water. That's why they float onto water. Rubidium, cesium, francium, these have a bit higher density than water, so they won't float. Okay, now strength and texture. All group 1 metals are actually soft and becoming softer as you go down the group. There's a reason behind this, we'll be discussing it. Okay, so the group 1 metals, we have learned that the group 1 metals are actually very soft. How soft they are? They can easily be cut with a knife, like soap. Okay, so and again they become softer as you go down the group. And texture, since they are metals, they are shiny and silvery, but when freshly cut. So when freshly cut, they're shiny and silvery, but quickly it tarnish on exposure to air. Physical properties, okay, have been explained. Now storage and handling. All these elements are extremely reactive. We have already discussed that they react readily with oxygen in the air and react rapidly with water, and all those reactions are very exothermic. Okay, all those reactions are very exothermic or highly exothermic. An exothermic reaction is a chemical reaction that releases heat. So a lot of heat is produced in the reaction between these elements and other reactants. Okay, so since they react readily with air or water in the air, they have to be stored very carefully. That's why lithium, sodium, and potassium are kept under oil to stop any possibility for air or oxygen getting at them. Okay, to keep them apart from oxygen or air, they're stored under oil. And since the reactivity increases down the group, the reaction between rubidium or cesium and water or oxygen will be more vigorous. That's why, to avoid any explosion or any vigorous reaction taking place, these metals are actually kept in sealed glass tube to stop any possibility of oxygen getting at them. Okay, and how to handle them? You can't touch them bare fingers. Why? There will be enough sweat on your skin for the elements to react with it and produce a lot of heat, which can scald your skin. Your skin may burn, and again the products formed, the hydroxides, are very corrosive. That's why they shouldn't be touched bare fingers. Storage and handling. A family of element. Okay. Again, look at their electronic configuration. 2,1 sodium, 2,8,1 potassium, 2,8,8,1. Okay. Now you can see that all these elements have one electron in their outer shell, and we have already learned that it is the number of electrons in the outer shell that actually determines the reactivity or the way an element reacts. Okay. The number of electrons in the outer shell determines the way an element reacts. Okay. So since all of them have one electron in their outer shell, they react in the similar way. Now let's know some chemical reaction and some product of them. Okay. First, all of the group 1 elements react with air to form an oxide of formula M2O. Okay. Here M represents any of the metals in group 1. For example, sodium oxide. Then all of these metals react with water to form a hydroxide with formula MOH and hydrogen as well. For example, sodium hydroxide, lithium hydroxide, potassium hydroxide. Okay, similar formula. All of them react with halogen, fluorine, chlorine, bromine, iodine. These elements are called halogen, and they are represented with a symbol X. Okay. All of these elements react with halogens to form a compound, an ionic compound with the formula NX. For example, sodium chloride, potassium bromide. Okay, with similar formula and react in the similar way. Then all of these elements form ionic compounds. All of these elements form ionic compound where the metal of group 1, will have an ion of charge +1. For example, sodium, potassium. Okay. In all the reactions they undergo, all the reactions group 1 elements undergo, they will form an ion with a charge of +1. For example, we again saying lithium ion, sodium ion, potassium ion, etc. Okay. Family. Okay. Now let's see how a reaction actually is observed when sodium reacts with water. Okay. Now we'll be studying the reaction between a group 1 element and water. For example, we are taking sodium as an example. Suppose this is water, a piece of sodium, and you'll observe that some observations are made. Observations. Okay. H2 evolved. H2 evolved. This is sodium. Okay. This is water, and there will be a white trail. Okay. Look at the diagram. When you drop a piece of sodium onto some water, you'll observe that the piece of sodium floats onto water. Why is that so? Because sodium is less dense than water. Okay. Next observation, you'll notice that the piece of sodium melts into smaller ball because the reaction between the sodium and water is exothermic, highly exothermic, and again sodium has very low melting point. That's why the sodium melts in smaller ball. I'm repeating. The reaction between, sodium melts into a smaller ball. Reason behind this, the sodium has very low melting point, and again the reaction is highly exothermic. So the heat produced is enough to melt the sodium. That's why the sodium melts into smaller ball. Okay, next observation. You'll see fizzing, or we can say effervescence, or bubbles of gas. Okay, bubbles of gas coming out, and this gas is actually hydrogen, and we won't be able to determine actually what gas it is, because during the reaction the gas produced, we know it is hydrogen, but it's colorless, so we won't be colorless and odorless gas. Therefore, we won't be able to understand what gas is being given up. But when you are asked to write down an observation, you will write fizzing seen, or effervescence seen, or bubbles of gas seen. Okay. Next observation, the sodium whizzes around or moves around on the surface. Why? Because of the production of hydrogen gas, and the gas is not given off symmetrically. Since the gas is not given off symmetrically, it pushes the sodium around the surface, but not evenly from all directions. That's why the sodium moves around or whizzes around on the surface. Okay. Next observation, you will see a white trail dissolving into the water. This is the sodium hydroxide that is dissolving into the water to form an alkaline solution of sodium hydroxide. Next observation, if you touch the beaker in which the reaction is taking place, you'll feel that the beaker gets warm. Why? Because the reaction is exothermic and heat is produced. And at the end of the reaction, when all the sodium is used up, if you place some or drop some universal indicator solution into this mixture, reaction mixture, the universal indicator solution will turn blue, showing that the solution is alkaline. Or you can also test this using litmus paper. If you place or immerse litmus paper, it will turn blue, showing the presence of hydroxide ions, which is actually responsible for a solution being alkaline. So these are the observations made when sodium reacts with water, and the reaction between lithium and water. Okay. Now look at the chemical equation or chemical reaction. Sodium solid plus water liquid. The product is sodium hydroxide and hydrogen gas. And if you react lithium or potassium with water, you will find similar results to lithium hydroxide, similar hydrogen gas. Okay, but you'll find some difference. Lithium reacts in the similar way as sodium, but there will be some difference. The lithium doesn't melt into smaller ball. Why? It will actually finally disappear, because when it is used up, it will disappear. But when sodium reacts with water, it melts, but lithium doesn't, because the lithium is less reactive than sodium. So the heat produced during the reaction between lithium and water is not enough to melt the lithium. And if you repeat the experiment using potassium, you will find similar result as sodium. Okay, potassium hydroxide plus hydrogen. But there will be also some differences. Okay, so the observations, some of the actually many of the observations are the same for potassium and sodium, but here are some differences. Since potassium is down the group, potassium is below sodium and more reactive than sodium, therefore the reaction will be more vigorous and more exothermic. That's why more heat will be produced, and the other things, other observations are the same. So the reaction is more exothermic, more heat is produced, and enough heat is produced to ignite this hydrogen gas when potassium reacts with water, and you'll observe a lilac flash when sodium reacts with water. Okay, reaction with water, observation, and rubidium and cesium way more reactive, so don't dare to react them with water in your school lab. Now, reaction with air. Let me erase it. All group 1 elements react readily with air in the oxygen in the air to form an oxide. For example, sodium, solid. Okay, all the elements in group 1 react readily with oxygen to form an oxide, which is a white solid. And if you burn them, using a Bunsen burner flame, you'll notice that lithium burns with a red flame, sodium burns with a yellow flame, potassium burns with a lilac flame, and they react in the same way, but down the group the reaction becomes more vigorous. Okay, for potassium, 4K plus O2 to K2O. Okay, similar reaction. Now we'll explain the reactivity. Okay, the trend in reactivity. We have already learned that all of them are highly reactive, and again reactivity increases down the group. Why is that so? Okay, when any of these elements react, they form an ion with +1 charge. Okay, when lithium reacts, it forms an ion of lithium by losing 1 electron, the outer shell electron actually. Lithium 2,1, sodium 2,8,1. Okay, for sodium ion plus electron. Look at these. All these elements, for example lithium, sodium, they form an ion with 1+ charge by losing their outer electron. And whenever a group 1 element reacts, it will form an ion with +1 charge to form an ionic compound. Therefore, the reactivity actually depends on how easily the outer shell electron is lost. The more easily the outer electron is lost, the more reactive the element will be. As you go down the group, lithium, if you look at the dot and cross diagram, sodium, as you go down the group, the atoms are becoming bigger. So the outer electron are further from the nucleus, therefore less strongly attracted, and that's why more easily lost. That's why down the group reactivity increases. Okay, I'm repeating it again since it's very important for you. All of the group 1 elements react to form an ion with 1+ charge by losing their outer shell electron, and the chemical reactivity or how reactive they are actually depends on how easily the outer shell electron is lost. And as you go down the group, the atoms get bigger, therefore the distance between the positively charged nuclei and the electron, positively charged nucleus and the electron increases. So the electron, since the electron, as you go down the group, the electron is further from the nucleus, therefore less strongly attracted and more easily lost. So the chemical reactivity increases down the group. Now I like to admit compounds of all of group 1 elements are ionic compounds, and they all are white solid, because all group 1 ions are actually colorless. So their compound will be white or colorless unless they are combined with any colored negative ion. For example, sodium chloride or potassium chloride, it is colorless because the potassium ion is colorless and the chlorine is also colorless. But when potassium is combined with a dichromate 6 ion, the compound is orange because of the presence of orange dichromate ions, not for the potassium ion. Okay, so all group 1 compounds are usually white or colorless, since the group 1 ions are colorless unless they are combined with any colored anion. And their solubility, all the group 1 compounds are soluble in water. Okay, now after understanding all those factors, now we can predict some properties of francium. For example, some physical properties, chemical properties. For example, physical properties, as we have learned that melting point, boiling point decreases down the group. So francium will have a boiling point that is very close to the room temperature. Density increases down the group, so it will not float onto water. Chemical properties, since chemical reactivity increases down the group, francium will be the most reactive one. That's it. This is the end of chapter 11, and solve the question answer at the end of the chapter, and let me know if you have any problem. Okay, I'll be there. Allah Hafiz.